Hello students and good morning to you all. So today I am doing class for class 12 science. The topic is problems on Rolle's theorem. So in the last online class also we did some problems on Rolle's theorem. So today we'll do more problems on Rolle's theorem. Okay. So it is exercise 3B 2 mark section. That is each question carries 2 mark section out here. And the page number is 307 from the book Higher Mathematics for class 12 by SND. So question number 2. So we were doing question number 2. So verify the truth of Rolle's theorem for the following functions. Now today we'll do number 13 of question number 2. So this is about your trigonometric function. So the function of x is given as sin x minus sin 2x in 0 less than or equal to x less than or equal to 2 pi. So this is known as the open interval. So this is known as the closed interval, because in this case x is equal to 0 and x is equal to 2 pi. X is equal to 0 and x is equal to 2 pi in this case, and x lies within 0 and 2 pi. This is known as closed interval. So you have to verify the truth of Rolle's theorem for the following function. F of x is equal to sin x minus sin 2x in the closed interval 0 less than or equal to x less than or equal to 2 pi. So you know the statement on Rolle's theorem, that is if f of x be a real valued function defined in the closed interval a less than or equal to x less than or equal to b, such that number 1 is f of x is continuous in the closed interval a less than or equal to x less than or equal to b. Number 2, f of x is differentiable in the open interval a less than x less than b. And number 3, f of a is equal to f of b. Then there exists at least one value of x, say x is equal to c, lying between a and b, such that f dash of c is equal to 0. So what is meant by f dash of c is equal to 0? That is the tangent at any point on the curve at x is equal to c is parallel to the x-axis. So there exists at least one value of x is equal to c, lying between a and b, such that f dash of c is equal to 0. So now there are three conditions there. That is, f of x is continuous in the closed interval, f of x is differentiable in the open interval, and f of a is equal to f of b. So first of all you have to check whether all these three conditions are satisfied or not in this problem. Okay. So now you know that every trigonometric function is continuous in its domain. You know that. And this is also sin x minus sin 2x. Both are the combination of trigonometric function. So you know that trigonometric function is continuous and differentiable in its domain, isn't it? That is, the trigonometric function is continuous and differentiable in its domain, right? So you know the meaning of domain. That is, those values of x for which the function f of x is defined is known as the domain, right? So now in this case also sin x minus sin 2x both are trigonometric function. So this function of x is continuous in the closed interval 0 less than or equal to x less than or equal to 2 pi. So you can directly write down here the function f of x is continuous in the closed interval 0 to 2 pi, right? Next, this trigonometric function is differentiable in the open interval 0 to 2 pi, right? The function f of x is differentiable in the open interval within first bracket 0 comma 2 pi. So if you write 0 comma 2 pi within first bracket, it is understood that it is an open interval, that is 0 less than x less than 2 pi. And you have to prove that f of a is equal to f of b. So in this case a here is 0 and b here is 2 pi. And you have to prove f of 0 is equal to f of 2 pi, right? So now you know that f of x is equal to sin x minus sin 2x. Now let us put x is equal to 0 here So f of 0 is equal to sine 0 minus sine 2 into 0, which is equal to sine 0 is 0 minus sine 2 into 0 is 0. So 0 minus sine 0, which is equal to 0. Okay, that is f of 0 is equal to 0. Now let us find out f of 2 pi. So therefore f of 2 pi is equal to, now in this case instead of x you write 2 pi sine 2 pi minus sine 2 into 2 pi. It is sine 2 into 2 pi, right? So which is equal to sine 2x, sine 2 pi minus, this is your sine 4 pi. As you know that sine n pi is always 0 where n is any integer, you know that, isn't it? So sine 2 pi is 0 and also sine 4 pi is 0, which is equal to 0. That is f of 0 is equal to f of 2 pi. So f of 0 is equal to f of 2 pi. That is, all the three conditions of Rolle's theorem is satisfied here. So therefore all conditions of Rolle's theorem, all conditions of Rolle's theorem is satisfied. So therefore there exists at least one value of x, say x is equal to c, lying between a and b. A and b means 0 and 2 pi. Lying between 0 and 2 pi, such that f dash of c is equal to 0. Right? So now we have to differentiate this f of x, right? Now differentiate f of x now. So here given is f of x is equal to sine x minus sine 2x. So we could have differentiated earlier also. Okay, so now here let's differentiate it because we have not differentiated. So let's differentiate it. Differentiating both the sides with respect to x. Therefore f dash of x is equal to, what is the differentiation of sine x? It is cos x minus, what is the differentiation of sine 2x? You know that it is cos 2x into 2. Or you can write f dash of x is equal to cos x minus 2 cos 2x. So I think you have understood it. So now since f dash of c is equal to 0, right? So since f dash of c is equal to 0, so what is the value for f dash of c? You put x is equal to c out here. If you put f dash of x is equal to c, this becomes cos c, or this is cos c minus 2 cos 2c, which is equal to 0. Understood? So now instead of x you have to write c in this case. So it is cos c minus 2 cos 2c is equal to 0. Right? So now what will you do? Now let us simplify it and let's get the value for cos c. Okay? So I am rubbing it, this one. Or cos c minus 2 into within bracket. So now you should know the formula of cos 2c. This is from multiple angles. So what is the formula for cos 2 theta in terms of cos? Since this first term is in terms of cos, you have to write cos 2c in terms of cos. What is the formula? It is 2 cos square c minus 1, right? It is 2 cos square c minus 1, bracket closed, which is equal to 0. Now let us simplify it. Or this is cos c, okay? Then minus 2 to the 4 cos square c minus minus plus 2, which is equal to 0. Or you can have minus 4 cos square c plus cos c plus 2 is equal to 0. Is that clear? So minus 4 cos square c. So it is plus cos c plus 2 is equal to 0. Is that clear? So next you take minus common. So within bracket 4 cos square c minus cos c minus 2, which is equal to 0. Since there is 0 on the right hand side, you don't have to write this common minus. So you just write 4 cos square c minus cos c minus 2 is equal to 0. So I think you have understood it. So now you have to get the value for cos c, but since you cannot factorize it, you have to get the value for cos c. So you can use PRHS formula. So you can compare it with ax square plus bx plus c is equal to 0. So instead of x, there is cos c. What is a here? 4. What is b? Minus 1. What is c? Minus 2. So therefore cos c is equal to minus b plus minus root over b square minus 4ac whole divided by 2a. So this is the PRHS formula. So now let us simplify it. Or cos c is equal to, what is minus b here? Minus, what is the value for b here? Minus 1 plus minus root over, what is b whole square? Minus 1 whole square minus 4 into, what is a? What is the value for a? It is 4. And what is c? Minus 2. All divided by twice a. 2 into, what is the value for a? A here is 4. Is that clear? So b is minus 1. B is minus 1 minus 4 into a means 4 into c means minus 2. All divided by 2 into a is 4. Right? Or cos c is equal to plus 1 plus minus root over, this is your 1 plus it is 32. Right? 4 4s are 16, 2s are 32 divided by 8. Or cos c is equal to 1 plus minus root over, this is your 33 whole divided by 8. Now let us simplify it now. So let us simplify it. What is square root of what is this square root of 33? So let us find out the square root of 33, right? So you can take the term in pair. So the pair of 3 is 3 only, 33. Okay. Now 5 5s are 25, 6 is a 36. But 6 is a 36, 36 is more than 33. So it cannot go 6 into 6 times. Now you can write 5 into 5. So here 5 5s are 25. Now you can subtract it 8. Right? So you can put decimal point here. If you put decimal point here, 2 zeros will be written after 8. Right? And you have to add 5 here. Is that clear? So now 5 plus 5 is 10. Now how much times it goes? Now 7 7. 7 7s are 49. 7 7s are 49, right? 7 1s are 7. Now subtract it. 10 minus 9 is 1. 9 minus 5 is 9 minus 4 is 5. Again you can put double zeros out here. So you can write here 7. So it is 7 7. 7 plus 7 14 4 1. This one. Okay. Now it you can write here 4 4. Right. 4 4s are 16 6. 1 4 4s are 16 plus 1 17 7 1. 4 1s are 4 plus 1 is 5. And 4 1s are 4. Right. So you can subtract it. So it is approximately 5.74. So or cos c is equal to 1 plus minus. So it is 5.74. This whole divided by 8. So taking positive sign and taking negative sign, taking positive and taking negative sign, you can have the values of cos c. So I think you have understood that square root. How can you find out the square root of 33? That is the method, right? So next, so taking positive sign, what do we get? That is cos c is equal to 1 plus 5.74 divided by 8. And the next one is 1 minus 5.74 divided by 8. So you have to take both the sign out here. So therefore cos c is equal to, this is 6.74 divided by 8. And the next one is you can subtract it. Because these are of different sign, you can subtract it. You have to write down the sign of the greater number now. So if you subtract it, what do we get? 5.741. Subtract it, what do we get? 47.4. That is minus 4.74 divided by 8. So now you know that the values of cos C, it lies between -1 to +1, isn't it? The values of cos C lies within -1 to +1. Is that clear? So that means you can have the values of C here. For the first term, what is the value for C? Cos inverse within brackets 6.74 divided by 8, right? And here you can get the value for C as C is equal to cos inverse within bracket minus 4.74 divided by 8, right? So we may have the values of cos C as 6.74 divided by 8 minus 4.74 divided by 8 because this value 6.74 by 8, it is less than 1 but greater than -1, and this minus 4.74 divided by 8, it is greater than -1 but less than 1. So both these values lies within -1 to +1. So cos C may have this value, right? Because you know that the value of cos C lies within -1 to +1, right? So minus 4.74 divided by 8, it is more than -1 but less than 1. This is 6.74 divided by 8. It is less than 1 but greater than -1. So both these values lies within -1 to +1. Okay. So if so here the condition is given x lies within 0 and 2 pi, isn't it? So in this case there exists at least one value of x, say x is equal to c lying between 0 and 2 pi, such that f dash of c is equal to 0. That means the value of c, this value of c lies within 0 and 2 pi, isn't it? Because you know that this, if cos c is positive, it lies in the first quadrant and in the fourth quadrant. And if cos c is negative, then it lies in the second quadrant and in the third quadrant. Is that clear? That means these values, these values lies, that is c, that is the value of c. That is the value for c will be an angle, and this angle lies within 0 and 2 pi. So we can write here, therefore 0 less than, then you can write cos inverse within bracket 6.74 divided by 8 comma cos inverse minus 4.74 divided by 8 less than 2 pi. Is that clear to all of you? That is, both these are angles. That is cos inverse 6.74 by 8, cos inverse minus 4.74 divided by 8. Both these are angles, and these angles lies within 0 and 2 pi. Because in this case cos c is positive and negative. Cos c is positive in the first and in the fourth quadrant, and cos c is negative in the second and in the third quadrant. That means both these angles lies within 0 degree and 2 pi. Is that clear to all of you? That is, these values of c lies within 0 and 2 pi. So यहाँ के भने थिए, कम से कम एउटा भ्यालु अफ c चाहिँ हुनु पर्यो जुन चाहिँ 0 देखि 2 पाइ सम्म पर्छ। तर यो दुईटै भ्यालु नै के पर्यो? यो दुईटा भ्यालु नै 0 देखि 2 पाइ भित्रमा पर्यो। भनेपछि Rolle's theorem is satisfied, or Rolle's theorem is verified. So hence you can write here, hence Rolle's theorem is verified. So it is proved. Hence Rolle's theorem is verified. So you can copy it. We'll do the next question now. So now we'll do next question, that is question number 3. So that Rolle's theorem is not applicable to the following functions in the specified intervals. Now we have to prove that Rolle's theorem is not applicable to the given functions in the specified intervals. So question number 1 is f of x is equal to 1 minus cube root of x square in minus 1 less than or equal to x less than or equal to 1. So this is any expression in x, isn't it? You know that cube root of x square means x to the power 2 by 3. It means that f of x is equal to 1 minus x to the power 2 by 3. So within this interval, that is minus 1 less than or equal to x less than or equal to 1, this f of x is defined. This f of x is defined within this interval. That means f of x is continuous in the given interval. So this is any expression in x, isn't it? And this expression in x is defined in the closed interval minus 1 less than or equal to x less than or equal to 1. So this function of x is continuous in the given interval, right? So you have to write here the function f of x. The function f of x is continuous in the closed interval minus 1 less than or equal to x less than or equal to 1. Okay, now let us differentiate it now. So differentiating both the sides, with respect to x. Therefore this f of x becomes f dash of x, which is equal to, for 1 it is 0. What is the differentiation of x to the 2/3? Minus remains same. Minus 2 by 3 becomes the coefficient x to the power, decrease the power by 1, that is minus 1/3, right? So, or what is f dash of x now? Now here, therefore f dash of x, so f dash of x is equal to, in this case it is minus 2 upon 3 into x to the power 1/3. So x to the power minus 1/3 is taken to the denominator to make it positive. Okay, so what do we see here? That is 0 lies within minus 1 and 1. So if you put x is equal to 0, this is undefined. So if x is equal to 0, then f dash of x is undefined. That is, we cannot get its value. It is infinity. Is that clear? That is, the function f of x is not differentiable in the open interval minus 1 less than x less than 1, because we see that in this case, if you put x is equal to 0, it will be minus 2 by 0, which is undefined quantity. That's why the function f of x is not differentiable in the open interval minus 1 less than x less than 1. So here you write, therefore the function f of x is not differentiable in open interval minus 1 comma 1. Okay, so this one of the conditions of Rolle's theorem is not satisfied here. So Rolle's theorem is not applicable in this function. So therefore Rolle's theorem is not applicable. So therefore Rolle's theorem is not applicable. Is that clear to all of you? So we have proved it. So you can copy it. We'll do the next question now. Now we'll do question number 3, number 2. You have to show that Rolle's theorem is not applicable in this function also. The given function is f of x is equal to tan x in the open interval, in the closed interval, 0 less than or equal to x less than or equal to pi. That is, Rolle's theorem is not applicable in this function f of x is equal to tan x in the closed interval 0 less than or equal to x less than or equal to pi. Okay. Now let us first differentiate it. So differentiating both the sides with respect to x. Therefore f dash of x is equal to, what is the differentiation of tan x? This is your sec square x, right? But you know that every trigonometric function is continuous in its domain. So likewise, this function of x is equal to tan x is continuous in the closed interval 0 less than or equal to x less than or equal to pi. Therefore the function f of x is continuous in the closed interval, that is 0 comma pi, right? Now since we have f dash of x is equal to sec square x, so you know that sec square x is 1 by cos square x, that is f dash of x is equal to 1 upon cos square x, right? So you know that, as you know that pi by 2 lies within 0 and pi, 90 degree. That is pi by 2 means 90 degree. 90 degree lies within 0 and pi. So if you put x is equal to pi by 2 here, this cos square pi by 2 will be 0. That is denominator is 0. If denominator is 0, 1 by 0 is, you know that it is undefined quantity. That means this f of x is not differentiable in the open interval 0 less than x less than pi. Because if you put x is equal to pi by 2, then f dash of x is equal to 1 upon cos square pi by 2. As you know that cos 90 is 0. So 1 upon 0, which is undefined quantity, which is infinity. You know that, isn't it? Which is undefined quantity. So when you put x is equal to pi by 2, this f dash of x is infinity or undefined. So hence you can write, therefore the function f of x is not differentiable. Is not differentiable in the open interval, that is 0 less than x less than pi. Therefore the function f of x is not differentiable in the interval 0 less than x less than pi. That is, Rolle's theorem is not applicable for the given function. So Rolle's theorem, so therefore Rolle's theorem is not applicable. Therefore Rolle's theorem is not applicable. Is that clear to all of you? So you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 3 of number 3. So in this case also you have to show that the Rolle's theorem is not applicable for this function f of x in the specified interval. Okay. So now it is given f of x is equal to within mod x minus 1 in the closed interval 0 less than or equal to x less than or equal to 0 less than or equal to x less than or equal to 2. So let us simplify this modular sign first. You know that this is the modular sign. So your modular sign ma cha bhane chahi यसलाई हामीले simplify गर्नै पर्छ. So how will you simplify it? So how can we simplify it? When you put x is equal to 1, it becomes 0. पहिला हामी के हेर्नु पर्छ, यो within mod sign को भ्यालु चाहिँ कति बेला 0 हुन्छ, x को भ्यालु कति हाल्दा चाहिँ 0 हुन्छ त्यो चेक गर्नु. त x is equal to 1 हाल्दा फेरि 1 minus 1 के भयो, 0 हुँदैछ हैन. So putting x is equal to 1, that is f of x is equal to within mod 1 minus 1 is equal to within mod 0 is equal to 0. That is 0 is neither positive nor negative. Now we have to check at when x greater than 1. If x is greater than 1, then f of x is equal to within mod x minus 1 means it should be always positive. So if x is greater than 1, so what can we say about x minus 1? It is positive or negative. So x minus 1 is always positive if x is greater than 1, isn't it? If you put x is equal to 2 here, 2 minus 1 is 1, that is positive. So you just have to write only x minus 1 because it is already positive. So if x is less than 1, then f of x is equal to, if you write only x minus 1 here, x minus 1 if x is less than 1, so it is negative. If x is less than 1 means you can put 0 here. If you put 0 minus 1, so it is minus 1. So it is always negative when x is less than 1. If x is less than 1, x minus 1 is negative, right? So to make it positive, you have to write minus sign out here. So it's equal to minus into minus plus 1. So it is 1 minus x. Is that clear? So now we can redefine this function of x is equal to within mod x minus 1. So it is defined as, therefore f of x is equal to 0 if x is equal to 1 is equal to this x minus 1 if x is greater than 1, right? And is equal to, this is 1 minus x if x is less than 1. So we have redefined the function f of x as this one. Okay. Now let us check whether the function f of x is differentiable or not at x is equal to 1. Right? त पहिला हामी डिफरेन्शिएबल छ कि छैन at x is equal to 1 त्यो चेक गरौँ. यदि डिफरेन्शिएबल आएन रहेछ भने चाहिँ the function the Rolle's theorem is not applicable भइहाल्छ. त यदि यो डिफरेन्शिएबल भयो भने obviously f of x is continuous at x is equal to 1. Okay? So in order to check whether the given function f of x is differentiable or not, you have to find out both right hand limit as well as left hand limit. In order to check that this function of x is differentiable or not, you have to find out both right hand derivative and left hand derivative. Okay? So for right hand derivative, okay? So for right hand derivative, what is the definition of right hand derivative? Capital R f dash of x is equal to limit h tends to 0 plus f of x plus h minus f of x, this whole divided by h. Is that clear? Now since we are checking the differentiability of the function f of x at x is equal to 1, so you put x is equal to 1 here. So putting x is equal to 1, right? So what do we get? Capital R f dash of 1 is equal to limit h tends to 0 plus f of this is 1 plus h minus f of 1 whole divided by h, right? So let us simplify this right hand side now. Limit h tends to 0 plus. So when h tends to 0 plus, what is the value for f of 1 plus h now? You should find out the value for f of 1 plus h when h tends to 0 plus. So what is the meaning of h tends to 0 plus? This is h greater than 0, right? Since you have to get the value for f of 1 plus h, you add 1 on both the sides. So it is 1 plus h greater than 1, right? So this 1 plus h, you can take it as x. So this is x is greater than 1. So when x is greater than 1, what is the value for f of x? It is x minus 1. So f of x, this is x minus 1, right? So f of x is equal to x minus 1 when x greater than 1. So you can put 1 plus h here. So it is f of 1 plus h is equal to 1 plus h then minus 1. Is that clear to all of you? So here you can write, what is the value for f of 1 plus h? This one. So it is 1 plus h minus 1. Then minus, what is the value for f of 1 plus h? It is 1 plus h within bracket then minus 1, right? Minus, what is f of 1? F of 1 means, what is the value for f of x when x exactly equal to 1? When x exactly equal to 1, f of x is equal to 0, that is f of 1 is equal to 0. X is equal to 1 also. So f of 1 is equal to 0. So it is 0 divided by h. Now let us simplify it. Your 1 gets cancels, is equal to limit h tends to 0 plus, this is only h divided by h, hs gets cancels, which is equal to limit h tends to 0 plus, this is only 1. Since 1 is free from h, so this one is constant. What is the value of this limiting value? What is the value of this limit? That is always 1. So it is positive 1. So right hand derivative is equal to positive 1. Is that clear now? So you can copy it. Now we will find out the left hand derivative. अब हामी लेफ्ट ह्यान्ड डेरिभेटिभ निकाल्ने छौं त पहिला यो कपी गरौँ. सो हियर राइट ह्यान्ड डेरिभेटिभ इज इक्वल टु +1. हामीले यति पायौं. ठीक छ त सार्नु यो. सो अब हामी निकाल्छौं लेफ्ट ह्यान्ड डेरिभेटिभ. So for left hand derivative, for left hand derivative, right? So for left hand derivative, so what is the definition of left hand derivative? Capital L f dash of x is equal to limit h tends to 0 minus f of x plus h minus f of x, this whole divided by h. Now since we are checking the differentiability of the function f of x at x is equal to 1, so you can put here x is equal to 1 here. So putting x is equal to 1, so what do we get? Capital L f dash of 1 is equal to limit h tends to 0 minus, so it is f of 1 plus h minus f of 1, this whole divided by h, right? So now let us simplify this right hand side, which is equal to limit h tends to 0 minus. Now when h tends to 0 minus, what is the value for f of 1 plus h? So how can you find out the value for f of 1 plus h? Okay, since h tends to 0 minus is here, h tends to 0 minus means h is less than 0, negative, right? That is, h is approaching to a 0 from the left hand side, so here h is less than 0. Since we have to get the value for f of 1 plus h, add 1 on both the sides, 1 plus h less than 1, so let us take it as x. So this is your x less than 1. Okay, so if x is less than 1, what is the value for f of x? It is 1 minus x, right? So f of x is equal to 1 minus x. So put 1 plus h for x. So f of 1 plus h is equal to 1 minus within bracket, 1 minus within bracket, it is 1 plus h, right? So here it is 1 minus, 1 is constant, 1 minus, instead of x you have to put 1 plus h here. Okay, so let us write here what is the value for f of 1 plus h here? 1 minus within bracket 1 plus h minus, what is the value for f of 1 here? That is, when x exactly equal to 1, what is the value for f of x? It is 0. So instead of x, if you put x is equal to 1 here, f of 1 is equal to 0. The f of 1 ko value kati bhayo? 0 divided by this one is h, right? So let us simplify it, which is equal to limit h tends to 0 minus 1 minus 1 minus h divided by h, here 1 gets cancels, so which is equal to limit h tends to 0 minus h divided by h gets cancels, so which is equal to limit, this is your h tends to 0 minus, this is your minus 1. So again minus 1 is a constant quantity which is free from h, so in this case you don't have to put the value for h in this case. So what is the value of this limit? Which is equal to minus 1. So in this case left hand derivative is equal to minus 1. Since we have got right hand derivative is equal to 1 and left hand derivative is equal to minus 1, so these right hand derivative not equal to left hand derivative, therefore the function f of x is not differentiable at x is equal to 1. So here you can write, since capital R f dash of 1 not equal to capital L f dash of 1, so what can you write? Therefore the function f of x, therefore the function f of x is not differentiable, at x is equal to 1. So hence Rolle's theorem is not applicable in this function. Hence Rolle's theorem is not applicable. Hence Rolle's theorem is not applicable. So this is the answer. Is that clear now? So one of the conditions of Rolle's theorem is not satisfied in this case, because in this case the function f of x is not differentiable at x is equal to 1. So Rolle's theorem is not applicable. So we'll do the next question now. So now we'll do the next question, that is question number 4 of number 3. You have to show that in this case also Rolle's theorem is not applicable for the following function in the specified intervals, right? The given function here is f of x is equal to 2 plus x minus 2 whole to the power 2 by 3 in the closed interval 1 less than or equal to x less than or equal to 3. Let us first check whether the function of x is differentiable in the open interval or not. That is, in the open interval, that is 1 less than x less than 3. So पहिला हामी check गरौँ whether this function f of x is differentiable or not in the open interval 1 less than x less than 3. So let us check it. Okay, so you can differentiate it, isn't it? So let us differentiate it with respect to x. So differentiating both the sides. So differentiating both the sides with respect to x. So therefore f dash of x is equal to. Now for this constant 2, what is this differentiation? It is 0, you know that, isn't it? Now this is the form x to the power 2 by 3. So it is 2 by 3 becomes the coefficient. Here x is x minus 2 whole to the power 2 by 3 minus 1 into, again what is the differentiation of x minus 2? It is always 1. The differentiation of x is 1 minus, for differentiation of 2 it is 0. So 1 minus 0 is always 1. Okay. So or this is f dash of x is equal to 2 by 3 into x minus 2 whole to the power minus 1/3, isn't it? So 2 by 3 minus 1 will be equal to minus 1/3. So you can simplify it further, or f dash of x is equal to 2 upon 3 within bracket x minus 2 whole to the power 1/3. So I think you have understood it, this one. So now whether this function f of x is differentiable in the open interval 1 less than x less than 3. So now for differentiation you should take it as open interval 1 less than x less than 3. That means 2 lies within 1 and 3, isn't it? If we put x is equal to 2 here, the denominator will be 0. So if x is equal to 2, then f dash of x is equal to 2 by 3 into 2 minus 2 whole to the power 1/3. That is f dash of x is equal to 2 by 0, which is undefined or infinity. That means the function f of x is not differentiable in the open interval 1 less than x less than 3. Therefore the function f of x is not differentiable in within first bracket 1 comma 3. Within first bracket means it is an open interval, that is 1 less than x less than 3. Because at x is equal to 2, this f dash of x is undefined. Is that clear? So the function f of x is not differentiable in the open interval 1 less than x less than 3. Is that clear to all of you? So now what can we say about the function? The Rolle's theorem is not applicable in the given function. So therefore Rolle's theorem is not applicable. So hence Rolle's theorem is not applicable because one of the conditions of Rolle's theorem is not satisfied in this case. So hence Rolle's theorem is not applicable. So is that clear to all of you? So we can copy it. We'll do the next question now. So now we'll do question number 5 of number 3. In this case also you have to prove that Rolle's theorem is not applicable for the given function in the specified interval. Okay, so here it is given that f of x is equal to x square plus 1 when 0 less than or equal to x less than or equal to 1. When 0 less than or equal to x less than or equal to 1, then f of x is equal to x square plus 1. Okay, now when 1 less than x less than or equal to 2, then f of x is equal to 3 minus x, right? So first of all, let us check whether the given function f of x is differentiable in the open interval 0 less than x less than 2. That is, you have to check whether the given function f of x is differentiable or not at x is equal to 1. Okay, so let us check it first. So you know that for right hand derivative, in order to check whether the given function f of x is differentiable or not, you have to check the right hand derivative. You have to get the value of the right hand derivative and the left hand derivative. If both of these are equal at x is equal to 1, then the function f of x is differentiable at x is equal to 1. Then it is obviously continuous at x is equal to 1. Okay, so let us check first the differentiability of the function at x is equal to 1. So let us write down for right hand derivative. For right hand derivative. For right hand derivative, let us check its right hand derivative at x is equal to 1 in this case. Because if you have x less than 1, the function is x square plus 1. If you have x greater than 1, the function is 3 minus x. Okay, so these are the doubtful point x is equal to 1. यो x is equal to 1 चाहिँ के भयो, doubtful point भयो, किनभने हामीलाई थाहा छैन whether right hand derivative is equal to left hand derivative हुन्छ कि right hand derivative not equal to left hand derivative हुन्छ. हामीले यो चेक गर्नै पर्छ at x is equal to 1. Okay, so here you can write capital R f dash of x is equal to limit h tends to 0 plus f of x plus h minus f of x this whole divided by h, right? So since we are checking the differentiability of the function at x is equal to 1, so you put x is equal to 1 here. So putting x is equal to 1. So what do we get now? Capital R f dash of 1 is equal to limit h tends to 0 plus f of 1 plus h minus f of 1 whole divided by h, right? So now which is equal to limit h tends to 0 plus. So when h tends to 0 plus, what is the value for f of 1 plus h? So what is the meaning of h tends to 0 plus? It is h greater than 0. Since we have to get the value for f of 1 plus h, add 1 on both the sides. So 1 plus h greater than 1. Now for this 1 plus h, you may take it as x greater than 1. So what is the value for f of x when x greater than 1? When x is greater than 1, f of x is equal to 3 minus x in this case. So f of x is equal to 3 minus x, right? So you put instead of x 1 plus h. So therefore f of 1 plus h is equal to 3 minus within bracket 1 plus h. Is that clear to all of you? So we can put the value here. So limit h tends to 0 plus, what is the value for f of 1 plus h? It is 3 minus within bracket 1 plus h, right? Then minus, what is f of 1? F of 1 means the value for f of x when x exactly equal to 1. X is equal to 1, f of x value the x square plus 1. That means you can put x is equal to 1 here. So f of 1 is equal to 1 square plus 1. So it is 1 square plus 1 whole divided by h. So I think you have understood it. Now let us simplify it further. Limit h tends to 0 plus, this is 3 minus 1 minus h, and this is minus 2 whole divided by h, right? So here you can cancel these 3. Minus 1 minus 2 means minus 3. 3 minus 3 is 0, so it is minus h. So which is equal to limit h tends to 0 plus, this is minus h divided by h. h1s are h, h1s are h, which is equal to limit h tends to 0 plus, so this will be minus 1. Since minus 1 is a constant which is free from h, so in this case you don't have to put the value for h because minus 1 is free from h. So what is the value of this limit? Which is equal to minus 1. So what is the value of the right hand derivative? Right hand derivative is equal to minus 1. So I think you have understood this right hand derivative. So let us find out the left hand derivative now. So you can pause the video and you can copy it. Okay. So let us do left hand derivative. So now for left hand derivative, for left hand derivative. So what is the definition of left hand derivative now? Capital L f dash of x denotes left hand derivative is equal to limit h tends to 0 minus f of x plus h minus f of x, this whole divided by h. Okay, since we are checking the differentiability of the function at x is equal to 1, so you put x is equal to 1 in this case. So putting x is equal to 1, so what do we get? Capital L f dash of 1 is equal to limit h tends to 0 minus f of 1 plus h minus f of 1, this whole divided by h. Is that clear now? So now when h tends to 0 minus, what is the value for f of 1 plus h? अब हामी यो कसरी निकाल्छौं? So let us write limit h tends to 0 minus here. So now what is the value for f of 1 plus h when h tends to 0 minus? So what is the meaning of h tends to 0 minus? H less than 0, because h is approaching towards 0 from the left hand side, and on the left of h is equal to 0, all the values of h are less than 0, so we have to write h less than 0. Now add 1 on both the sides, 1 plus h less than 1, right? So for this 1 plus h we can take it as x less than 1. When x less than 1, what is the value for f of x? It is x square plus 1. So f of x is equal to x square plus 1, right? When x is less than 1, what is the value for f of x? It is x square plus 1. So f of x is equal to x square plus 1. Now write f of 1 plus h. So what is f of 1 plus h? Now it is 1 plus h whole square plus 1. So I think you have understood it. So now let us put f of 1 plus h is what? It is 1 plus h whole square plus 1, right? Then minus f of 1. So you have to write minus. So what is f of 1 now? F of 1 means the value for f of x when x exactly equal to 1. When x exactly equal to 1, what is the value for f of x? It is x square plus 1. So put x is equal to 1 here. So f of 1 is equal to 1 square plus 1, isn't it? So 1 square plus 1. So whole divided by h. Is that clear? Now let us simplify it. So which is equal to limit h tends to 0 minus. So what is 1 plus h whole square? 1 plus 2h plus h square plus 1 is out there. So minus 1 square plus 1 is 2. So here we can cancel plus 1 plus 1 plus 2 minus 2 gets cancels divided by h. Okay. So is equal to limit h tends to 0 minus. So h is common here within bracket 2 plus h whole divided by h. Here h gets cancels. So which is equal to limit h tends to 0 minus. So it is 2 plus h, right? So if you put h is equal to 0 in this case, 2 plus 0 is equal to what? It is 2. So I think you have understood it. So are they equal? So in this case, right hand derivative was minus 1. Right hand derivative was minus 1, isn't it? Right hand derivative was minus 1 and left hand derivative here is plus 2. So here right hand derivative not equal to left hand derivative. Therefore the function f of x is not differentiable at x is equal to 1. So let us write it here now. Since r f dash of 1 not equal to L f dash of 1. So therefore the function f of x is not differentiable at x is equal to 1. So what can we write here? Hence one of the conditions of Rolle's theorem is not satisfied in this case. So hence Rolle's theorem is not applicable. Hence Rolle's theorem is not applicable. Hence Rolle's theorem is not applicable. So this is your answer. त आज हामी यति नै गर्छौं. त आज जति पनि प्रब्लमहरु गर्यो सबै घरमा रिभिजन गर्नु. त नेक्स्ट क्लासमा म तिमीलाई लाग्रेन्जेस मिन भ्यालु थ्योरम गराउँछु. ठीक छ? त नेक्स्ट अनलाइन क्लासमा हामी गर्ने छौं लाग्रेन्जेस मिन भ्यालु थ्योरम. त तिमीले घरमा यो पनि रिभिजन गर्ने प्रब्लम्स अफ रोल्स थ्योरम अनि लाग्रेन्जेस मिन भ्यालु थ्योरमको स्टेटमेन्ट फेरि एकपल्ट तिमीले हेर्नु. त त्यो एकपल्ट त्यो हेर्यो भने चाहिँ यस्तै रोल्स थ्योरम जस्तै नै हो. खाली डिफरेन्स चाहिँ के हुन्छ भन्दाखेरि त्यहाँ रोल्स थ्योरम र लाग्रेन्जेस मिन भ्यालु थ्योरममा के डिफरेन्स छ. सो रोल्स थ्योरममा चाहिँ एउटा एफ अफ ए इक्वल एफ अफ बी पनि हुन्छ. तर लाग्रेन्जेस मिन भ्यालु थ्योरममा त्यो एफ अफ ए इक्वल एफ अफ बी हुँदैन. त लाग्रेन्जेस मिन भ्यालु थ्योरम र रोल्स थ्योरममा एउटा के दुईटा चाहिँ सेम छ भन्दाखेरि एफ अफ एक्स इज कन्टिन्युअस इन द गिवन क्लोज इन्टरभल, एफ अफ एक्स इज डिफरेन्सिएबल इन द ओपन इन्टरभल. ओके, यो चाहिँ सेम छ. तर रोल्स थ्योरममा एफ अफ ए इक्वल एफ अफ बी हुन्छ. तर लाग्रेन्जेस मिन भ्यालु थ्योरममा त्यो एफ अफ ए इक्वल एफ अफ बी हुँदैन. Then there exists at least one value of x, say x is equal to c lying between a and b, such that f dash of c is equal to 0 for Rolle's theorem, but f dash of c is equal to f of b minus f of a divided by b minus a for Lagrange's mean value theorem. The एकपल्ट चाहिँ तिमीले त्यो statement of Lagrange's mean value theorem चाहिँ हेर्नु. Okay, so this much is for today, so you can copy it. Okay.